on the left corner of the Teams. So everything that we are doing now is recorded. Okay, the recording has started, so we can start the meeting. Can you confirm last time, Sarah, that you can see me, hear me well, see the camera?
I can see you on camera and I can see your screen.
Awesome. Good morning or good evening to all, and welcome to the Data-Driven Community virtual meeting. My name is Ronen Arieli, and I'm from Israel. I serve as a senior consultant and an architect in the field of developing and data platform, and I'm honored to be here and host this meeting today. Each meeting is a great opportunity to remind about a few upcoming community events, and the most important upcoming online conference is the annual conference of the Data-Driven Community. Please mute yourself, there are some noise, so make sure that everyone are muted. Thank you. As I start to mention, we have a big conference on September 28th. I'm proud to be part of the team that organized the event, and we will be very happy to see you all joining us. If you are fast enough, then you can scan the QR code right now, or simply check the recording after the meeting. Another event, which it's a must to mention, is the PAST Summit, which will be held on November. If you want to present in one of the future meetings of the Data-Driven Community, then please contact Jen Joseph, the administrator of the community. At this point, please turn off your camera and microphone. If you have any questions or just a comment, then please use the chat. I will try to follow the chat and pass the questions to the speaker from time to time. Today we are hosting Sarah Dutkiewicz. Sarah is a Microsoft MVP in developer technologies. She published a powerful book, organized the conference and hackathon, and she lead the product and speaking in technologies event and user group, just like this one. So Sarah, you can share your screen and take the control.
Excellent. Thank you, Ronan. Let me go ahead and share. All right. Can you confirm that you can see Predicting Flights with Azure Databricks, the slide deck?
Yes, we can see it. You can continue.
Awesome. Thank you. All right. So as Ronan said, my name is Sarah Dutkiewicz. I'm also known in the tech community as Saduki. Today I'm going to talk with you about predicting flights with Azure Databricks. So we're going to take a look at Azure Databricks. We'll also look at Azure Data Factory. Hence the two logos you see here. So let's get to it. So we're going to take a look at the flight prediction scenario. We'll talk about where it came from. What is Databricks? We'll take a look at getting to the solution and looking at Databricks throughout the way we go. Looks like we have a question.
No, you can continue. I will give you the question from time to time. We cannot stop every second.
Good deal. All right. So in our scenario, this is a group called Margie's Travels. It is a fictitious group, very much like Contoso or Tradewinds, things like that. So this is a group for traveling for business. They want to know, based on flight information and the weather prediction, whether a departing flight is going to encounter a 15-minute or longer delay. Now, this 15-minute longer delay is something that is standard in the transportation industry. Basically, if it's going to be more than 15 minutes, there's a field that will represent it that is a 1. So we'll talk about that field here a little bit. The data that we're working with is from 2013. It's just sample data. It includes 2.7 million flight delays with their airport codes, the examples, and then the features are 20 columns. Now, when it comes to training the model, so we're going to take our data, we're going to use the decision tree algorithm because we're either deciding whether it's going to be late or not. So 1 or 0, it's a binary classification. And we're using the Spark MLlib. Again, part of the data is going to be used for training and another part will be used for testing. So the flights, they're going to have this column called DepDel15, which is understanding the delay. Is it going to be more 15 minutes or more for a departure delay? If it's going to be there, it's going to be set to 1. Our sample will keep all of the delayed, and it's going to downsample to 30% of not delayed. We've got one hot encoded categorical variables, and we'll use a pipeline. The reason why we have to use the pipeline is because we're going to be doing multiple steps, and we need the pipeline to bring it all together. It's a threefold cross-validation, and we're going to save the model and use it in other notebooks and in case we have cluster restarts. Now, I saw a couple questions about, is the session being recorded? Yes, it is. And then, is the data set available from Kaggle? I don't believe so, but I have a link that will come out here about 12:30 Eastern time on Twitter to the GitHub repo that this is based off of. So this is based off of a Microsoft Cloud workshop. It was called Big Data Analytics and Visualization. The repo is marked as archived because there's nobody maintaining it currently, but just be aware that this will be there.
There was another question that asked before, will the Databricks notepad become available in GitHub?
So all Databricks notebooks that are mentioned in the slides are part of the GitHub repo link that I will have on Twitter at, like I said, about half hour after. I have a bunch of tweets scheduled.
The recording, we already got 4 questions, and I answer all of them the same. Yes, this meeting is recorded, and the recording should be in the Data-Driven Community YouTube channel. Follow the community announcement, and you will find it as well.
Like a plan. All right. So this is the architecture that we're working with for our general scenario. You'll see that we have our CSV files. Let me grab my laser pointer. I'll draw that. So you should see that there's the flight delay data, the historical airport weather data. Those are CSV files. They're all the materials needed to go through this scenario are included in the GitHub repo. So the CSV files are there, the notebooks are there, the information like step by step, how do you get started with this? All of that is included. I'm going to walk through it though, so that way you can see how can you work with this. Oh, Ronan, there's a question. Can you enable live transcripts? Do you have that permission?
I'm not sure if this is a good idea, but 1 second, we'll see.
And with live transcripts, please do not change the language because it changes it for everybody.
Yeah, that's a problem, that it's all or nothing. This is what I said. I'm not sure it's a good idea.
Okay.
So let's leave it like this, and on YouTube we can put the translation of YouTube.
Okay. All right. So we have here, then there's Azure Data Factory. There's our blob storage. This is, we'll show this pipeline. This is going to come out later, but we start with Azure Databricks. We'll take a look. There are 3 different work environments, so we'll show those. I do have slides to show this visual delay. Again, this comes from the Microsoft Cloud Workshop, which gets into things where we have applications and we get into Azure Key Vault, Azure Monitor. Those are outside of the scope for today. We only have a short period of time, and so I'm not getting into all of the details, but I'm going to focus on the data part of it all. Okay. So what is Databricks? Well, we're working with 3 different types of workloads. We have Databricks SQL for querying your data lakes using SQL. You can create queries, you can create visualizations from those queries. When I've delivered this in the past, I actually get into Databricks SQL, but for today, because I wanted to focus more on the other things, I've omitted Databricks SQL. Just be aware that's your SQL environment. But Databricks Data Science and Engineering and Databricks Machine Learning are going to be the focus of our talk here. Databricks Data Science and Engineering, this is the classic Databricks environment. So if you've used Databricks over the years, this is our tried and true, this is what we know works. This is used by data engineers, data scientists, it's used by ML engineers. If you're doing ETL, this is a great environment to be working with. It uses the Apache Spark ecosystem. You can use multiple languages, we'll show that. Databricks Machine Learning, this gets into your experiments, your models, your features, and this gets into how you serve the models so then you can run through it. So we'll take a look at those. But first, let's talk about loading the data. So you're going to have 3 CSV files. One is flight delays with airport codes, one is flight weather with the airport code, and the other is the airport code location lookup. The lab will take you through like the CSV files and how you go about importing those into Databricks. And those are this is the table to see how the CSVs and their names line up. But before you can even load the data, you need to create a cluster. So once you create your Azure Databricks resource in Azure, then you'll have to launch the workspace. And then once you launch the workspace, you can create the cluster. Now, when you create a cluster, this is what's going to be doing all of the work for us. So you're going to see various different options to choose from, but there's going to be the runtime version. Now, runtime version, there are non-machine learning runtimes as well as machine learning runtimes. So when you select that, you need to make sure that you pay close attention. If you need machine learning, to select the ML runtimes. The other thing to pay attention to with the MLs is that there are GPU and non-GPU. So that is this part right here. So you can see that we are not using a GPU runtime, but we are using a machine learning runtime. Now this photon acceleration is a newer feature, so I'm not going to show that. Just be aware that I have it unchecked for our cluster. Auto scaling I have disabled at the moment because this is for a demo environment, but if you need it in a production environment, that feature is there. We have the terminating after inactivity, just again, keeping our costs down. We're working with 1 worker, and our standard F4 is the worker type that we're playing with our driver type the same. Now, other things to note is that there's support for Spark config and environment variables. And while the screenshot doesn't show it, we have a config set up so that we can connect to our Azure Storage. So we'll be working with that. So again, clusters, they can be set up as high concurrency, single node, or standard. We're looking here at a standard cluster. Auto scaling, like I said.
1 second, Sarah.
Sure.
We have someone that put his hand up, probably to speak, Parash. So in general, please use the chat and not speaking because we don't have time in a short meeting. At the end of the meeting, we can open the stage for everyone to use the microphone. At this time, Parash, if you really feel that you must say something, so please tell me in the chat, and we will give you a few seconds to speak. Okay? You can continue.
Yeah. So these are the various other options to know about. So when it comes to workers and drivers, there are different optimizations available. They can be optimized for compute, memory, storage, and then there's also GPU acceleration. Now those GPU accelerated workers and drivers, that's going to be when you have the GPU enabled runtimes. There's integration with Azure Data Lake Storage. There's, again, the Spark config and environment variables. In this walkthrough, we use the Spark config and we use a connection string to go to our Azure Data Lake using its key access. And then you can use initialization scripts, but this demo is not going to show that. All right, so when we loaded our data into Azure Databricks. And I say loaded because I did all of this ahead of time. Again, short period of time. I don't want to do live demos and get sitting around waiting. But we do create a new table. When we do this create table, so under Azure Databricks, there's a data section, and then you tell it to upload a file. And then I pointed it at my CSV file. And there are going to be two different options. I can create the table with the UI or create the table in a notebook. We're going to use the UI just so you can walk through and see what we're working with. There are two different types of tables to know about. There's the global tables. These are accessible across all clusters. And then if you have local tables, this is just for one cluster. So if you find yourself in your work environment that you have multiple clusters and you need that data accessible by multiple clusters, you'll create a global table. Now, when it comes to creating a table, the steps we take is first we upload a file, then we create the table. In our demo, we're going to create it in the UI. We need to assign it to a cluster. So handy dandy laser pointer. So we assign it to a cluster. This is the cluster that I created. Then you're going to preview the table. It does it every single time. Things to note. So you can set the table name. You can choose a database, so you can have multiple databases within your Databricks instance. The CSV is the file type. The column delimiter will automatically be picked up, but if it doesn't work like you anticipate it, you can always change it and specify the delimiter. First row is a header. You'll need to check that if that's the case. It can infer the schema, and then multi-line. I would say when you have it bring in your data, double check what it's coming in as. Different data platforms have different inferencing schemes where they inference from, I know one of them, I think it was Synapse inferences off of 10 rows. So you need to kind of take a look and see, make sure that these data types are what you anticipate them to be. If you have multi-line rows, you can check that and then tell it to create the table. I had to go through that for all three tables that I mentioned earlier. So we have all three of those loaded in our data. All right, so Databricks, data science and engineering. Again, this is the classic Databricks. If you've been using Databricks for years, that's what it's used for. It's the powerhouse. It is the underlying thing for both Databricks, data science and engineering, and machine learning. This is their backbone. Key things to note. So there are workspaces, runtimes, clusters, notebooks, and jobs. I will not be focusing on jobs much. We will look at notebooks. Clusters, we just talked about creating one of those. Workspaces, I'll show you what that looks like here in a moment. Now with this lab, there is a notebook for data preparation, and it is labeled O1 data preparation. What we're going to do, you'll want to explore the data, take a look at the data, and kind of shapeshift it as you need it, and then take it from there. Now, the notebook that we use has multiple languages. So let's do this. Let me flip over into my Databricks. So I have Databricks open here. Just give it a minute to refresh on screen. Do you see Microsoft Azure Databricks, Data Science and Engineering?
Oops, I was muted. Yes, we can see.
Okay, so welcome to Databricks live demo. Getting away from the slides for a minute. So the way you can tell I am in Data Science and Engineering is you can see the D. If I drop down, you can see there's also SQL and machine learning. So when we're in a smaller menu, that'll be your key giveaway as to which workload you're in. Now, in terms of workspaces, you can have shared, which is works well across organizations. But I'm going to go to users, and then myself, and then this big data viz folder. This is part of the lab. So part of the creation process, it'll walk you through the lab of creating the folder. You import a file and it brings in all of these other things too. So the question about notebooks, these notebooks are all part of that lab. And so here's the data preparation notebook. Now, what's nice about this notebook is that we're working with multiple languages, and you can see which language it is based on the cell. So like that's a markdown cell. This is a Python cell. I can scroll down a little bit more. You can see now we have a SQL cell. There's also an R cell in here. So we have all different languages. Now you might be wondering, why would you work in multiple languages? Well, different languages may have different purposes based on your experiences. If you find that you're better off quickly cleaning things using Python versus R, for example, maybe you bring in the Python modules, or you bring in the R modules, you play to your strengths. This particular notebook will show multiple languages so that you understand the features and understand how to switch between them. Something to note with those. Let me zoom it in a little bit. Yep, thank you, Fernando, for the link. Fernando posted a link in chat to the MCW, the Big Data Analytics and Visualization. That is where this presentation comes from. All of these files are in there, but you can see there's the SQL. So we use these magic indicators, the %, and there's all different ones. I have a slide to explain what those are. But the workspace is your collection. So I've got notebooks. We have another notebook for batch scoring, which we'll talk about batch scoring later, and then exploring the data after batch scoring. So just so you can see after the batch scoring process runs, what does that data look like? So we will come back to this, but just so you're aware what this looks like. Oh, I guess one more thing while I'm still in here, let's look at data. Oh, my cluster's not up at the moment. That's under compute. And there's my lab cluster. So I'm gonna go here, and then I'm going to unzoom so I can tell it to start. Confirm. All right, we'll come back and I'll show you data later. Let's go back to our slides. All right, do you see preparing our data?
Yes, we can see the presentation.
Okay, cool. I don't know what the delays, sometimes I've seen bigger delays in slides and video changes, so just making sure.
Today it's very fast. I told you before the meeting, you shared your screen and immediately it was shared.
Well, now I'm on a wired connection and I have a laptop with a GPU, so I'm armed here with some serious.
Okay.
Serious connections. All right.
Yeah, and this is a great advantage in a virtual meeting. You can mute yourself for a second when you need.
Exactly. Exactly. That's why I have this headset too, because it's real quick. All right, so we showed workspaces, did a live demo to see what's contained in there. You can work with your notebooks, your libraries, and experiments. I'll show experiments later, but let's move forward. And there is some integration with Git repos, but I'm not going to show that today. Again, because we've got only so much time and so much to show. All right, clusters. So clusters, again, are the things that make, they're the things that make things happen. They're the runners. They're the energy behind it all. They're your compute, they're your memory, everything is in there. It supports your workloads for data engineering, data science, and data analytics. It does take some time to start. Notice that I saw my cluster wasn't running, so we started it and I came back to this. When we get back to it later, it will have been running. It just takes a little bit to go. There are two types of clusters to know about. There's the all-purpose ones, which can be shared, and they're manually managed. That's the one that we created. But then there are also job clusters. So when we tell things to run, they'll create their own clusters. They're managed by the job scheduler. They're created and terminated by that. You don't need to worry about any of those. They cannot be restarted. So know that, yes, there are other clusters you may see, but the ones you really want to manage and worry about are the all-purpose. All right, and this is where, again, another screenshot of the clusters. Runtimes. Runtimes are assigned at the cluster level. This is what provides the engine, what version of the platform you're working with. This includes your Delta Lake storage. GPU-enabled support appears in the ML flagged runtimes. So the standard versus the ML, if you need GPU-enabled, go with the ML. This is running with Ubuntu and their system libraries, and it supports 4 languages. It supports Python, R, Java, and Scala, in addition to the Spark SQL runtimes. So that's why you'll see Python, R, and we don't have any demos of Java and Scala, but they are there. Now, when it comes to runtimes, there are special runtimes. So the ML ones, those are the Databricks runtime for machine learning. There's Databricks Lite. And then there's the Photon-enabled runtimes. Now, when I initially did this presentation back in March, they were in public preview. The option is there for creation. but again, that's a newer feature and not one I'm going to be able to show in today's demo. Now, notebooks. This is why I showed the notebook earlier, is because you can do a presentation of all your data using different languages and then mixing in Markdown to make notes and clarify things and show the transition between your data. You can mix Markdown with various languages. This particular data preparation demo that we show has Markdown, SQL, Python, and R. Again, the key that I showed with those, and I'll show it again on this next slide, is the notebook cells. So with the notebook cells, things to note, you're going to have this command number. The command number on each cell is a good indicator of how far in your notebook you are, because what you can do is you can create a notebook, and then when you're done with the initial creation, you might want to just run all of your cells at once. There's an option at top to run all your cells. It'll go through each cell and it has an indicator telling you which cell it's on. So use this as your guidance as to where you are in your notebook. You also have these execution details, so you can see how long did the command take, who ran it, when did they run it, and on which cluster. This particular one, this is a Python command, and this is its output. All right, next up, SQL Notebook cell. So with the SQL Notebook cell, so you can see with this, the %SQL. So these magic commands, they start with %. They are called magic. I don't make up the terms, I promise you. The magic commands are what tells the SQL or the engine what language it's working with for that cell. If it doesn't show it, it's going to be whatever language is set for the notebook. By default, you're going to see Python, but then also there's SQL, there's R, MD is Markdown, that's Scala, SH is for a shell, and %FS is for the file system. You can also then do something like this demo here shows pprint, which is the pretty print library from Python. And this gives you an idea of what kind of data we're working with. So looking at the data frame, we want to see the columns and the types that all got imported as strings. Thankfully, we're not dealing with it.
The code is a bit small to read.
Yeah, that's.
Yeah, that's.
Yep. So you can see these are our columns. And like I said, all the data right now got imported as strings, but we're not doing any numerical calculations, so we're not going to change any of that over. Nothing that we need to convert for at the moment. Now, when it comes to data munching, and I'm going to zoom in on this so you can see there's a lot more text going on in here. But this is using Spark R to clean. R in the same notebook as SQL, in the same notebook as Python. To some people, that would be like, that's mass chaos. To others, like, well, we use the tool for what we need. Now, looking at this cell, the %R, that's the magic method to say we're using R. And then when you click in one of the cells in the notebook, to the right, that'll be your indicator as to whether it actually picked up the language properly or not. So you'll see here, there's the R. But then we're doing things like there's a SQL query that we're using, then we're getting rid of the missing values and kind of cleaning it up, making it a little bit easier. This is just the output from the R command. Like, what is Spark R? We don't need to look through that right now. But
obviously, you can do the opposite. You can execute Python from Transact SQL from the SQL.
Yep. You can put SQL and Python. There's all sorts of languages getting mingled on this presentation. It happens. Now, as I mentioned earlier, there are two different types of tables. There's the global tables and the local tables. The way you're going to do this with the Spark syntax is if you see save as table, that's a global table. Global tables, again, can be accessed by all clusters. If you see create or replace temp view or register temp table, those are your local tables. Those are just for that cluster. And you will see in the notebooks, there's a lot of save as tables. So there's a lot of global tables, just like this one right here. So this is once we have our flight delays cleaned up, we're going to overwrite it if the table exists. If the table doesn't exist, it will create it. But then we're going to have that table flight delays clean. With the cleaning weather data, So they ended up using Python for it. I want to zoom in just so you can see the kind of steps that were taken for it. So you're going to see that we're working with a data frame, and then we're taking through any missing hours, any missing wind speeds, things like that. We're going to see sea level pressure, precipitation. This is all done in Python. Notice here, it says for DF, there's that PySpark.sql.dataframe. So you are using PySpark for your syntax. So these are PySpark data frames, not pandas data frames. For any of you who are like, oh, data frames, it must be pandas. Not in this case. In this case, we're in the Spark environment, so it's a PySpark data frame. All right. So we start in data science and engineering because that's the core. But now let's get into machine learning, where we get into machine learning specific items like experiments, feature stores, and models. So Databricks machine learning is built right on top of data science and engineering. You're going to see the same workspace components. So you do see the repos, you do see the data, compute, and jobs. Those are all the same that we saw in data science and engineering. The difference now is we have experiments, feature stores, and models. Let's switch over to my Databricks. That way you can see what this looks like. So if I go back to Databricks, notice my lab has a check. So cluster is started. I mentioned earlier where we create data that is here in data science and engineering. Once a cluster is started, you go to create table. This would be where you would put the CSV, choose whatever CSV you need, and it will do the upload, and then you'll do the prompts that you saw on the slides. But I am going to show you, just so you can see no tricks up my sleeve, that my workspace has all these notebooks. We've seen under data, under default, if it loads, it should load those tables already created. There we go. So there's the airport code, things like that. And then compute. So there's my lab cluster. I'm going to switch over to machine learning. Now I see there's a question about passing variables from one language environment to another. That's where you see things like how they're mixing SQL and R and SQL and Python. So you can do it if the language allows you to support it, but passing them between the cells otherwise, you have to populate it in one cell to pass it to another.
Between the cell, you cannot directly pass it, but you can pass it inside specific language which support another language. We have just mentioned that you can run SQL queries inside Python or R or any other language, and vice versa. SQL support languages like Java, Python, and R, and .NET. So you can do it inside specific cell. There is a trick to pass between cells, which is not actually pass between cells, but using a session variable key value, which was added in 2019 version of SQL Server. So you just configure a key value in the SQL Server, and then you can use it in another cell.
Now I'm in the machine learning environment. And if I go back, you can see there's my workspace. All the notebooks that I had in data science and engineering are still here in machine learning. So those are still the same. My data is still the same. Loaded a little bit quicker there. The compute is still the same, but now we have experiments, feature store, models. Those were not available in data science and engineering. Those are specific to the machine learning environment. You can see there's experiments. So in O2 train and evaluate, this is one of the notebooks. It will create this experiment. If you go in the experiment, you can see I ran it 5 days ago. So I've been going through this lab multiple days in a row just to make sure it's working. Because the last thing you want is to show demos and then kaboom. Feature store, there is no demo for that. Not today. But then registered models. So when we go through the batch scoring, in order to run the batch scoring across what we've already done, we have to make sure that we are hosting this, we are serving this. So we have this thing called the delay estimator. Is our flag going to be delayed or not? And then we have endpoints for being able to hit the service to see we can then pass in other things and say, okay, based on what we've run, can you predict whether this is going to be delayed or not? So this is what we have under the covers, is we have this served. The lab goes step by step with what you need to do. There are parts in there where you have to fill in like your storage name and an access key, and then it'll walk you through this. Now, when you're going through the lab, something to be very mindful of is when you go to serve this model, you don't want to proceed until both the status up here at the top is set to ready and your version 1 is set to ready. If you try to move forward and one of them is not set to ready, it will not work. I used to run this lab with a bunch of other folks, and every time we would run into it, inevitably somebody would get excited and they copy and paste the URLs and press play and wonder why it's not working. Wait until it says ready and then it'll work. Otherwise, it doesn't like that. All right. So with the experiments, those are again created in the O2 train and evaluate models notebook. Specifically, command 27 will take care of that. It does use the ML flow to trigger the experiment via code. Now, if you go through the lab and you create a cluster and you forget to put it in an ML cluster and you just have a standard cluster, this ML flow will fail in the notebook. So if you go through the lab and you get to this point and it failed and you're like, why can't it find ML flow? It's because you have the wrong type of cluster. Don't panic. It just means then you need to create a cluster that's using an ML runtime and then rerun through the first notebook and then back into this notebook. So when ML flow is not found, it just means that you have the wrong type of cluster set up. I've been there, I've done that. So that's why I pass this information on to you all so that you don't run into that and panic either. The experiments can be done for yourself, or you can share them across your organization. Now, when it comes to creating your own AutoML experiment, that's an option. There are various ways you can do AutoML. So first off, you need to make sure that your machine learning runtimes are 10x or higher if you need to deal with a forecasting problem. Forecasting has to be 10x or higher. Classification and regression, those are supported across all the other runtimes as well. When it comes to evaluating your metrics, you've got for classification, it supports F1 score, accuracy, log loss, the precision, the ROC AUC, so the area under the curve. With regression, it supports R squared, your mean absolute error, your mean squared error, and your root mean squared error. This is all for AutoML. Now, I don't have any AutoML experiments running for the demo, but just be aware that this is a feature that is supported in Databricks. In the notebook, you're going to be able to train and evaluate the models. Again, we're using PySpark. There's a question about no recall. I did not see recall in the list of things that were supported. Oops. All right, let me zoom in. Not letting me zoom in. Why is it not letting me zoom in? Okay. So with the train and evaluate models, there's my zoom. Oh, there we go. Okay. You'll end up running through, there's a command 10 will run a query, which will allow you to analyze things. Now, the main thing I want to point out with this particular cell, the output is already set for visualization. By default, the cells are going to tables. That's what this bottom left corner, this button is here. Let me grab my laser pointer again. I can point it out. That's here. But next to it, you can do visualization. So you can do bar graphs, and there are a bunch of other visualizations there. Yet another feature when working with Databricks is being able to visualize your cells output. All right. And again, for this particular scenario, what we'll be doing is we've loaded the data with clean data. We sampled the data using the departure delay by 15 minutes. Either it is or it isn't. We need to select the algorithm. We chose binary classification again. It's one thing or another. We're using the string indexer and the one-hot encoder estimator for converting our categorical variables into a one-hot representation. And then that pipeline API, because we do these things in multiple steps, that pipeline API allows us to then combine our results into one set of results. Once we have the model processed and transformed, then we're going to save that model for batch scoring. Now with batch scoring, we're going to use an Azure Data Factory pipeline to move our data, and then we're going to run that through our notebook, all within Azure Data Factory. So the question of is the data set balanced? So we're looking at a stratified sample, and the stratification of that sample is explained. I don't know if we have it in here. We had it earlier where it talks about how it's it kept the delays and it stratified the other part by 30%. All right, so batch scoring, again, is going to be reading from Azure Data Storage. We have data frames for the CSVs. We're going to load the trained model. We're going to make predictions against that set. Then we're going to save the scored data in a table called scored flights. It's going to be a global table. So we have to register the model with MLflow. We have to move the model to production, set up that model service, test the service, and then once it's good, then we'll set up the pipeline. Now, register the model flow and move the model to production is handled in the notebooks. Setting up the service, that is explained in the notebook. To do it manually, you have to come in here and enable serving and then wait for it to be ready. Testing the service, there's a cell at the bottom of that notebook for testing the service, and then it'll give you the directions on setting up the pipeline. So the lab, again, has all the steps that you need to go through this. Now, Azure Data Factory is the pipeline that we're using, and it'll work with the notebook. So we'll talk about how we set this up. So we have a data lake. We're just using Azure Storage. Our CSVs, so I have the CSVs on my hard drive, and then I have the integration runtime, which will move it from my hard drive to Azure Data Storage. Azure Data Factory is the one that will work with the integration runtime. The integration runtime, you download an installer off a website, you run it on your machine, then you leave that running on your machine, you go into Azure Data Factory, you add your integration runtime, you copy a key from Azure Data Factory to your runtime, and that way they can talk. The runtime needs... What's that?
If you can look at the chat, there is a question a bit long.
The Azure Data Lake Storage configured in Databricks. Does that mean you don't need to mount Azure Data Lake Storage in Notebook when you try to write data in Azure Data Lake Storage? Correct. You're not mounting it in the Notebook. So I have that set up it's at the cluster level. When I created the cluster at the bottom, there's that Spark configuration. That's where I tie the connection string. That way I don't need to pass any of that in Notebooks at all. But I do have to use the storage name in the batch notebook. And that's because that's going outside of the Databricks. Because it integrates with the Azure Data Factory process. It's not like you're in Databricks running it right there. So you mentioned that part is on the cluster itself. When you create a cluster, scroll down to the Spark config. And when you go through the lab points that out on cluster creation, that you need to have both your storage account name and the key. And then it has a particular string with the format as to where you put the account name and where you put the key. So that's tied up at the cluster level. So does it matter what kind of language is chosen for a cluster? So you can switch between languages as we showed with the data preparation one, starting with PySpark and using R. If you're using R, just make sure you're using the magic methods. I want to be mindful of time. So I'm going to move forward here and we'll gather a few more questions here in a little bit, Ronan, if that's okay. Okay. Azure Data Factory. So this is where we're moving our files from on-prem, or in this case on my machine, to Azure Storage. And then what's going to happen is in our pipeline, we're going to take it. So we have that copy data task, and then we're going to send the results over to batch score. Batch score is an Azure Databricks notebook that is going to work with our endpoint that we published earlier. So it's going to check to see, based on what's getting fed in and based on our model, what is the prediction. So what do we need? We need to set up an integration runtime. This is the thing that handles running things, moving from our local machine to Azure. Then Databricks is going to do the batch scoring. We publish our changes in Azure Data Factory. So there's going to be a publish up here, and you would tell it to publish. And then finally, we trigger the pipeline. We just tell it to run now, rather than waiting on a trigger. Locally, just so you can see what it looks like, I have on my hard drive, I have a folder called data, and my integration runtime has access to this data folder. That is key. But then there's flights and weather, and then there's all this data here, various CSVs. Flights and weather CSV appears for each of the months. All of these files are included in the GitHub repository. So you don't have to panic like, where did this come from? How do I get them? It's all in the GitHub repo. In Azure Storage, just so you can see what my setup is. So we're going to have, it's a Spark container, and I have a folder flights and weather, and then it's going to be 4-digit year, 2-digit month. There's my flights and weather files. With the pipeline, so when you tell it to run, you can also monitor it and see where it's at in your pipeline. As you're running your pipeline, let me see, there, cool, it'll let me zoom this time. We've got, the indicator is in the upper right for each step of the pipeline. So when I took this screenshot, it was just working on copying data. And you can see in this activity run section that it was in progress. There was nothing else underneath. It only showed the activity currently running. When it was done, you could see the different activities. You could see when the activity started. You could see the status. There are additional fields as well. So you can monitor your pipeline in Azure Data Factory, and you can see batch score is a notebook. So that's where it gets into the Databricks part. All right, so our batch scoring notebook, again, it's got the CSV schema, it's got the saved pipeline model, it makes the predictions, and then it's going to write a prediction to the global table called scored flights. There are different ways you can view the results. So you can view the results in Databricks SQL if you wanted to, or you could also do a notebook. This is the query we run in the notebook. Notice there's a %SQL magic method. And then here's a long query. Rest assured, it's in the notebook, so you don't need to try to take a screenshot and save it and then copy paste from later. Use the notebook in the GitHub repo. But just so you can see what happens with the results. It has some coordinates, displays. There are more columns over here, including the prediction information. Now that's all fine and dandy, but once you have Databricks, it's got the data, maybe you want to visualize it. Maybe you're like, Databricks, I can create visualizations in Databricks SQL. I could do some visualizing in my notebooks, but I have my analysts who like using Power BI. Can they access the data in Databricks? And the answer is yes, you can use Databricks as a data source within Power BI. So that's this section that we're going to look at in the architecture diagram. Let's look at Azure Databricks as a source and visualizing the prediction on a map. All right, I know there's a question about the GitHub repo. If you scroll back up and chat a little bit, around 12:19, so 19 after the hour, Fernando posted a link to the GitHub repo. It's GitHub, Microsoft, MCW, Big Data Analytics and Visualization. All right, so in Power BI, when you tell it to get data, then if you do a search for Azure Databricks, you will see Azure Databricks in the responses. There's another option that appears nowadays too, like a Databricks preview, but we want Azure Databricks specifically. Then the lab will take you through and it'll show you where you can find it. So when you look at your cluster, there's a JDBC, ODBC section, and in there you'll be able to find your host name and your HTTP path. You paste those into here, and when you tell it OK, it'll go through the same Power BI dialogues where it shows you the tables and your data, and you can pick and choose what tables you need. Now here we're looking at our summary information, just so you can take a look at what's available data-wise. We did visualizations with a map. We also did a tree map, and then we also did the day of the month. And trying to find a location, because I know this group is all over the world. I happen to notice somebody was in New Jersey for some reason. And I'm like, well, LaGuardia is kind of close. And I noticed that. So let's look at LaGuardia's track record based off of the data set. Maybe go over to Power BI. You all see Power BI? Yeah, cool. So my Power BI is pulling off of my Databricks. I am going to close my field and close my visualizations. And we can leave filters there. It's not going to hurt anything. But that way you can see that as I hover over, I've got some latitudes, longitudes, number of delays, tree map. I can filter it. So for example, I'm in Northeast Ohio. I'm in Cleveland. I can see how bad Cleveland looks. Notice when I filter on my tree map, it's also filtering on the map. And it is also filtering down below. So working in Power BI, pulling that off of my Databricks. I can also bring up my Databricks again so you can see. I pull out Databricks. All that data. If I go into my workspace and I go into exercise 6, explore data, you can see the scored flights in that as well. So there's a question about, does the repo contain the notebook from today's session? There are 6 different notebooks, and all those notebooks are part of that repo, correct? As you go through the initial setup, so there are 2 files. There's the before HOL and the hands-on lab. Those are what you're going to want to go through. I can pull that up here as well. Got a few more minutes, and I can show you the last couple slides and pull the GitHub link over again. So with additional resources, I will make sure I get the slides over to you, Ronan. That way you can share that with the group. And then that way you all have these links. So Microsoft Learn, I'm currently doing a blog series on Microsoft Learn and Microsoft Docs and how awesome they are for learning about Azure products, because there's so many out there. How do you know where to start, and how do you get started with them today? So Microsoft Learn's Pathways, this is how you get started with Databricks, data engineering, data science, machine learning, as well as their user guides. Let me pull up the GitHub just so you can see. Okay, so in the GitHub, I'm going to zoom so that we can actually read it a little bit. This is the repo that the presentation was based off of. The hands-on lab is what you would go through. And specifically, you start with the before the HOL. So I guess, let me step back a minute. How many of you have heard of Microsoft Cloud Workshop? Yes, no, thumbs up, something like that. Microsoft Cloud Workshops allow you to see how to work with various Azure services and how to integrate them together. It was one of those that I just started working with one of my clients. Unfortunately, a bunch of them have gotten retired. So if I do a search for Microsoft Cloud Workshop, it should be .com, yep. And I'm going to scroll down past the top stuff so you can see there are different categories. There used to be a whole lot more, but a bunch of them got retired. They didn't have the support that they needed for getting maintained. And so that's why they've been retired. However, the products are still there. All the exercises still work to the best of their abilities prior to retirement. So that way you can go through and see. In this particular one, you get to see how Azure Data Factory and Power BI and Azure Databricks, how they all work together. So Microsoft Cloud Workshops help with that, but they all follow a similar situation where there's a whiteboard discussions, and then there's also the hands-on lab. The hands-on lab, they all have a before. The before will tell you the steps you need, the resources you need. It'll help you with creating the resources. Rest assured, you don't have to create these resources individually. Most of them have ARM templates or bicep templates, and they give you step-by-step what you need to do. So if you're like ARM templates, bicep templates, how do I use those? Rest assured, all of those are explained here in this lab. In the before hands-on lab, it's getting all your stuff set up. Now it talks about the integration runtime running on a VM. You can run that on a VM. If you want to just demo it locally, you can demo it locally. There are options for that. There are talks of Visual Studio in the hands-on lab. Let's take a look at that. If you want to take a look at creating an application and publishing it and having it talk with your Databricks, that's an option. But again, due to time, I'm not going to show that. But this is the hands-on lab, step by step. What's nice about these, go past the boilerplate, is it breaks it down into exercises and tasks and going through step by step on how those work. So if you're going through and you're like, okay, now I'm to the point where I need to set up Azure Data Factory, for example, and I could go right there, drops me right down there. This is the AdventureWorks sample data. Again, our flights and weather data, all of these things that are called out, all of the CSV files, things I used in today's demo are here in this lab. They're the links to access them. I want to show you another spot to note. So I'm going to come back up into the code. In the hands-on lab folder, there's this lab files. So if you go into lab files, notice here, this is where you see zip files. This is where you're going to see things like big data travel. You'll see the solution. So this is the code for later on for the stuff I'm not showing. And then big data viz for who's the one who keeps asking about that? I believe it was Hong Zhu. Heads up. Exercise 2, exercise 5, exercise 6, those notebooks you keep asking about, rest assured they are here in the GitHub repo. They're in this hands-on lab files, big data viz, and then exercise 2 is where the first 3 are, exercise 5 and exercise 6 have the others. Does that help to see that too?
Yes.
Awesome. Awesome. All right. Well then.
We don't have a lot of time, so we need to close in about 2 minutes to move to the closure, and then we can open the stage if you have more time to stay with our audience.
Sure. So if you have any questions, I am on Twitter as Saduki. I'm also on LinkedIn, linkedin.com/in/Saduki, Sadukie. Feel free to reach out to me with these questions as well.
I will move to the closure slide of the session.
Sure.
And if anyone wants, you can use the chat now. We will open a few minutes according to the time that Sarah have for a short open stage. So feel free to continue with the questions.
Well, thank you all for coming and asking questions. This has been a great audience.
And in the meantime, first of all, a great session, Sarah. A lot of interaction with from the audience, which means that it was great. So thanks a lot for sharing the knowledge with us. And I want to thank everyone that joined us today. Please remember to register to the Future Data Driven Conference, which will be held in September 28th. And if you want to help in running the conference, then you are welcome to contact one of us, and there is place for volunteers. So thank you all. And Sarah, do you want to answer a few more questions?
Sure, I could be around here for a few more questions.
So there was a question in the back. If anyone have a question which we missed, please put it again. What is the link to the GitHub? Do we have it?
So this is resources. Whoa.
The presentation should be available to you. I think that Jen published it every meeting, so all the links are there.
All right, there's the resources.
Awesome.
And then we'll get the GitHub.
Okay, we are right on time. So thanks a lot again to everyone that came, and especially to our speaker guest, Sarah. Awesome session.